Okay, next we are covering the equation of a line, slope of a line, how to find your slope. We're going to be doing some really basic examples with whole numbers because it's just going to give you the foundation that you need and the kind of the reminder so that whenever you go into a chemistry problem and they say, hey, find the slope of this line for the reaction between time equals 3 seconds and time equals 9 seconds, you know, like, well, time, your final time is 9 seconds, your starting time was 3 seconds, and so that's how you use, anyway. It can be used with decimals, exponentials, logs. It doesn't matter what they give you. It's all the same basic rules, right? Okay, so equation of a line. Hopefully this jogs some memory. Y equals mx plus b. M is your slope, okay? What do we know about slope? Hopefully you remember slope is rise over run, okay? Rise over run. Rise is not always positive. It can be negative. It can also be 0, okay? And run can also be negative or positive. It depends on which direction you're going and how you're thinking about it. All right, so that's slope. M is your slope. X is a variable. B is your y-intercept. Your y-intercept is where your line crosses your y-axis, okay? So it's where your line crosses your y-axis. It could be positive, negative, doesn't matter, but that's where your y-intercept is because it intercepts the y. All right, slope of a line. This is your basic equation for a slope, right? Your final y minus your initial y over your final x minus your initial x. What's that mean? Well, first of all, looking at this is a super basic graph. You can automatically, hopefully, if you're in college, hopefully you can tell me, well, your rise is going to be +1 and your run is going to be +1. So 1 over 1 is 1. So your slope is going to be 1, right? And your y-intercept here is +1. So it would be, your equation of your line would be 1x plus 1. And then you simplify that to be x plus 1. All right. Up here, you can use this to do the same thing to find that slope of 1 by, say, going between, say we want to take it between seconds 2 and 3, right? Say this is, say x is in time, all right? Time in seconds. So let's go in between seconds 2 and 3. So your final is going to be 3 seconds, right? So your final x is going to be 3 seconds minus your initial x. We said between 2 and 3, so your initial x is going to be 2. So 3 minus 2 on the bottom. Now we go back and we fill in the top. Your final y, so you go to 3 and you follow this up. 1, 2, 3. This is 4, okay? So it intercepts at 1, 2, 3, 4. All right, minus, now we go to 2 seconds here. We go 1, 2, 3. It intercepts at 3. So if you simplify this, you're going to get what? 4 minus 3 is what? 1. Over 3 minus 2 is what? 1. That equals a slope of 1. So that's how you use this slope of a line equation. Same situation over here. Say we want to take, say this is also in time for seconds, okay? T in seconds. And say we want to take it between T 1 second and T 2 seconds. So let's write our equation. M equals our final time on the x-axis is going to be 2. So our final time we're going to write in as 2, okay? Minus our initial time. We said we were starting from 1 second. All right, so minus 1 second. Now up here, we're going to go to the 2 second mark on the x-axis. We're going to count up until we intersect that line, okay? 1. It's a plus 1. Positive 1. Okay? Then you're going to subtract your final, or sorry, your initial y. So you're going to go over here to your initial x here, and you're going to count up. 1, 2, 3. All right? So that's 3. So here, you can already tell we're going to have a negative slope of a line. 1 minus 3 equals negative 2 over 2 minus 1 is a positive 1. Negative divided by a positive is a negative. So your slope equals negative 2. When you go to write the equation of the line, you can see here that your y-intercept is positive 5. So your equation of the line is going to be y equals your slope, negative 2, x, plus your y-intercept. Okay? So there we've covered how to find slope, how to find your equation of a line. Generally speaking, not generally, this is always speaking. If you're in the first quadrant, I guess we should cover this too.